Assalamualaikum, hi student. I would like to continue the second one and the last slide for chapter number 7 about contour map. Okay, what is contour map? Okay, contour map is actually a species geographic distribution. This is called contour map. Okay, density fall off at age figure 8.5. Gradual decline from center of density to edges. Okay, there are also be unexpected boundaries due to physiological and biological factors. Okay, this is a contour map. Okay, class, please make sure you know how to draw out this diagram completely and correctly, because it's very important for you to know. Might be the question might come from this test or quiz or whatever might come from this topic. Okay, so if you look at that figure 14.1, this is typical relationship between distribution in space and density for a species. Okay, areas of optimal habitat support the highest density and surrounded by suboptimal habitats with lower densities. Okay, outside the circle there are no organisms, so followed by low density, and the middle one moderate density, and the last one the small round in the middle is high density. Okay, this is just an example. I think we have discussed this one last time about a kangaroo. What are they actually located at the western grey kangaroo located in Australia. Okay, range size and abundance. What's that? Okay, this is correlation between range, size, distribution and abundance. Data shows the common species or abundant species generally tend to be widely distributed. Okay, on the other hand, rare or threatened species will have narrow distribution. Okay, narrow distribution. Common or abundant species is not most species. Rare or threatened species is not few species. So if you look at figure 8.5, 8.6 later on after this, showing a relationship between distribution and abundance of 263 more species. Okay, similar pattern in birds, plants and other groups. Okay, if you look at that again, distribution for small geographic range, you have more species abundance, and large geographic range, you only have few species. Okay, again, this is about what I've told before about figure 6.8, relationship between distribution of abundance for 260 species of British moth. Okay, distribution is the number of trap site errors Britain at which the species were caught. Okay, abundance of this averaged across all sites for all years. Okay, each dot represents one species in In general, species with wider distributions are more abundant. Okay, this is from Gaston 1988. Okay, next, this is another example. The relationship between the distribution abundance of 170 species of berry plants. So this is for a plant. Okay, on 433 quadrat in Konza Perrine Research Area of Central Kansas. Distribution measured by number of plot occupied, abundance measured by mean percentage cover for each species. Okay, the round one means one species. The half color, blue color, means 2 to 9 species, and the full color of the blue light color is means more or more species. This is from Getterly and Simberloff 1987. Okay, this is about some endangered and threatened species. Okay, this topic also important for you to understand. Okay, about this is an example. So the key deer, Florida. This is endangered species. So this is the same thing, endangered species: Philippine eagle, Chinese river dolphin, Javan rhinoceros. Okay, and many more. Okay, you can read by yourself this one. Okay, this one also. Okay, we take a look at here. 3 reasons why distribution and abundance are correlated by Hansky's 1982 rule. Okay, guys, again, please make sure you know how to recall about this rule. Okay, by Hansky's 1982. Okay, reason number one is about sampling model. What's that? Okay, observe relationship if an artifact does not require biological explanation. The above applies is as in figure 8.6, okay, about moth species, but positive correlation has been shown among birds, butterflies and mammals. Design number 2, ecological specialization model. Okay, this is Brown's model. Species that can exploit a wide range of resources become widespread and common. And number 3, local population model. Based on dispersal ability in local patches of population, species differ in their capacity to disperse. Some occupy more patches. Okay, patches. Species that disperse more occupy more patches that and become more common and when compared to less migratory species. Okay, next. Okay, more this is about distribution abundant again. More widespread species generally tend to be more abundant, dispersed more. This is more common species. If a species is declining in number, thus its geographic range also decrease. So this is important for conservation of declining species. Our species increasing in their numbers extend their geographic range. You can take a look at figure 8.7, shows data of birds. Meadowlark reduce their geographic range, but grackles increase their geographic range. Okay, this is about what I've told you before, two types of birds here. Okay, the blue color one and means they are decreasing, and the red color one they are decreasing. They're increasing actually, and the blue color one they are decreasing. Okay, so the blue color one, as their abundance decrease, their geographic ranges also decrease. Proportion of ruffles occupied. Okay, the blue color one, as their abundance is increased, their geographic range decrease. Okay, so population rows occupied. Okay, you just take a look the arrow. Okay, they will decrease and increase. Okay, I think that's all about chapter number 7. Thank you for your cooperation. Thank you.